When we normally use the word information, our meaning is colloquial. We use this term very informally to convey its informal meaning, but it has a very formal mathematical definition as well. For a really enjoyable explanation of the formal meaning of information and its history, a recent book by James Gleick is highly recommended. In the context of advertising and news, information has a very important role to play. Many of you will remember the scandal that broke last year in the British media world, and you may have wondered, like I did, why did these people do these obviously illegal things? Well, simply so that you and I read their story and they become more and more popular. To put it simply, a story about a dog biting a man is not newsworthy at all. It happens very often. But if you reverse the words and a story is about a man biting a dog, well, it becomes interesting because this doesn't really happen that often. Why is news so much about the scandalous events, the rare events, the unexpected? As it turns out, Claude Shannon, in his famous 1948 theory about communications, defined the term information formally as being related to surprise. In particular, a message informing us that some event has occurred, an event which normally has probability p of occurring, while such a message conveys a precise information content, which Shannon argued was exactly minus log of p. Let's look at this for a moment. If p is 1, then log of p is 0. So a message that informs us that an event which is guaranteed to occur has actually occurred is not really telling us anything new. So the information content is 0. On the other hand, if p is close to 0, that means the event is very rare, then minus log p is a very large number, telling us that a rare event conveys a large amount of information. Equally importantly, Shannon defined the term bit, saying that a message informing us of an event of probability p conveys minus log p bits of information. Now, one might wonder whether this bit has anything to do with the bits that we are all used to. Well, it's exactly the same bit, and here is why. Think about the Morse code, where letters are encoded by dots and dashes, which is used for communication via telegraph. Outdated now, but very common at the time of Shannon. Notice that letters E, A, I, which are the most common letters in the language, are encoded with a small number of symbols, whereas less common letters are encoded with longer sequences. Similarly, notice that the more common words in language itself have the shorter spellings, and the rarer words have longer spellings. Quite simply, words or even artificial codes naturally encode those items which are more frequent with smaller numbers of bits, reserving the longer sequences or the longer bit sequences for the rarer items just for efficiency purposes. And this is the relationship between bits and surprise. Another way to understand this is to see what happens when p is 0.5, or when you're tossing a coin, which can be either heads or tails, 1 or 0, the information works out to be exactly 1. So the news of an event which tells us that one of two equally probable things have occurred conveys a bit of information. In fact, the concept of information is so deep, not only for our digital world, but for our entire universe itself, that some physicists, such as John Wheeler, have suggested that the entire laws of physics can be derived directly from information. Yin and yang, it from bit. Well, all that sounds very interesting, but let's now return to our discussion about news, newspapers, and what it takes to make news sell.